Today, I'll show you how to build your first RAG AI agent in n8n. You want AI that understands your business information. Now, you might think it's very complicated to build or requires a ton of coding, but the good news is it's very simple. I've been building AI solutions for businesses for the past 6 months, and I've learned there are 3 components that you need in order to implement RAG. So in this video, I'm going to show you step by step how to set up each component so you can have your RAG AI agent up and running. And all of this will be done without writing a single line of code. Let's dive in. Before we hop into the technicals, I want to just spend a bit of time explaining some key concepts. So firstly, what is RAG? So RAG stands for Retrieval Augmented Generation. You can think about it as an AI tool that gives large language models extra knowledge. It's a way of connecting information retrieval with the text creation that a large language model does. So the benefits of this is that it makes the large language model or the AI more accurate and less prone to errors. As we all know that large language models are baked in with a whole heap of information. Now that information might not be specific enough for your business. So by implementing RAG, you can provide it information and context about your own business and also provide it the most up-to-date and current information and not just the training data. These are the 3 components that you need in order to build a successful RAG agent. The first one is your large language model. These are pre-trained on vast amounts of data that's been scraped from the internet, and they allow the detection of natural language, and then they generate text based on that. The second part of this is your vector database. A vector database is something that stores data as vectors, and essentially, without making it too complicated, you can just think vectors as a huge string of numbers, and this is what really enables the RAG part of the system to quickly get that information and bring it back to the LLM. And the last and probably the most important component of all of this is your input data. So this could be like documents, articles, or even videos, images, anything that you have as part of your business or as part of your informations. So that gets converted into those vectors or those string of numbers and then gets stored into the database. Now let's dive right into the technicals, and I'm going to show you how to build out this AI RAG agent. We're now here in the n8n workspace, and I'm going to teach you how you can use those 3 components that I just talked about to build your first RAG AI agent. So we're going to start off on the opposite end of the spectrum, and I'm going to start with the data aspect of it. So here I've got a flow which looks at how do you actually insert information into your vector database. This trigger kicks off the workflow. When I hit the button, then it goes to a code block. So just for the sake of this example, I've kept it very simple. And what I've put inside this code block is just a Python variable, and it's got in string format information about the bakery. It's got the open hours, services that the bakery provides, specials, and why you should visit this bakery. And then it just returns that information as an output. The next step that it goes to is the vector database. Now, there's different providers that give vector databases. For the sake of this example, I've just started off with an in-memory vector store. What that pretty much means is that it's going to store that information in the vector database that's hosted within this n8n instance. It's not a third-party vector database provider. I'll be presenting that in future videos in terms of how you can connect it to third-party vector database providers. So you need to choose this in-memory vector store module, and the operation that you want to start off with is insert documents, and it's just got a memory key here that's auto-generated. And you need to connect 2 different things to this module. The first one is an embeddings model here, or this embeddings node. So I've chosen the embeddings OpenAI, and the reason why you need embeddings, or what this module actually does, is it will take this information that's coming as strings, and it's going to convert it into vectors. So if you recall, what vectors were those numbers or those different numerical representation of that information. So that's essentially what this module here is doing. The other thing that we need is this default data loader. And what this data loader is essentially doing is it's taking the information that's coming in, and it's going to look at loading that information into the vector database. So if we have a look, we can define what type of data is going to be coming in. So we're going to say we've selected JSON here, and the mode is we're just going to be loading all the input data. We can also choose to load specific data, but for this example, we don't need to worry about that. And then the last thing we want is a text splitter. So what this element does is it defines the chunk size. Now, what the chunk size is talking about after how many characters do we want to split that information? Now, imagine if you have a massive wall of text. You can't just take that entire wall of text and just shove it into the vector database. You need to chunk it up and split it into parts, and then those parts then get turned into those embeddings or those vectors. So here we're choosing to choose, we've chosen a chunk size of 1000, which is, I think that was the default one that it started off with. So now I'm just going to show you this whole flow in action. So right now, if I go test workflow, it's going to run it and the test flow has successfully been created. So now, as you can see here, the information that we've put in the bakery info, so we've got that we've got that string. And here you can see in terms of the output in the vector database, saved all of those, that information. And as you can see, we've got two different blobs here, which is how the information has been saved. It's been saved into two different chunks here. So just with that, we've loaded our input information into the vector database. And now I'm going to show you those other two components. Then I'm going to talk you through the second component, which is the LLM or the agent itself. So we've got a trigger here, which is a chat window. And this is going to be our primary method of communicating with the agent. Trigger then goes to the AI agent module, which has a few different connections that need to be made. So the first one itself is the LLM or our chat model. So the chat model that I've got here is the OpenAI Furrow mini model. That's the one that you need to attach to this agent node. The second one that we have is the memory. Now, the memory is a very important part. If we're using the chat interface to communicate with our agent, the agent needs a mechanism to understand what has been said and to remember our conversation that's been had. So we're currently using the in-memory window buffer. There's different databases that you can attach to this as well. There's Postgres database or another SQL type database that you can attach to this. But for the time being, we're just going to stick with the in-memory database as it does the job well. And then lastly, we've got tools. So tools are very important for AI agents as they allow them to perform different tasks or allow them to access information that's not baked into their training data. In this case, the tool is going to be the third component, which is the vector database, and we're going to be retrieving information from that vector database that we stored earlier in step 1. So we've got a vector store module attached as a tool. If we double click into this, you can see the different types of settings that we have here. So there's a few different operation modes that you can choose from. We want to choose the retrieve documents operation and specifically as tools for the AI agent. And then it's important that you put a little description here. And this description helps the AI agent understand when to trigger this tool. So this particular vector database, we want to use it to answer questions asked by the user about the Smith's Bakery. And similar to the flow above, you need an embeddings node here, which attaches to the vector database. And what this embeddings node does here is it takes the query that we're going to be putting forward to the agent, and then it converts it into embeddings or vectors. And I'm going to show you step by step exactly how this whole agent works right now. So let's open the chat and put in the message. So I'm going to say, hi there. I want to find out when the bakery is open on Saturday. There you go. We've got a response. Smith's Bakery is open on Saturday from 6 a.m. to 6 p.m. Now what I want to do is I just want to take a peek inside each one of these components to see what's happened. So if we have a look into the AI agent node first, we get a few input variables. The first one's the session ID. That's how we know what conversation that we're pursuing. And this is the chat input, which is the message that we have. And you can see the output of this agent is the bakery's open on Saturdays, 6 a.m. to 6 p.m. That's cool. So that's the end answer. But what we want to understand is how we actually got to that answer. So let's have a look inside. Let's see what's happening inside each one of these nodes. So if we have a look at the chat model, you can see that we've sent this message through. It looks a bit weird because it's been converted into a string with these \ns pretty much means new lines. And you can see that there's a response from the AI agent and it's provided us from the LLM and it's provided us that text here. It also gives you how many tokens it's used as part of this exercise, which is important information. And you can see there's a few other bits of information in terms of your model name and the prompt and the generation info, just a bit of background information. If we look inside our window memory buffer, this will then show you what are the responses that have been saved. So here you can see we've got our input messages and you've got the system message as well. So this database stores everything that we've put into it and also what the agent understands. So we've got the input message here, we've got the system prompt, and then in terms of the outputs, you can see it's saved the system message here, and it's also saved the output of the agent in this. So if we were to keep messaging with this agent, this list will grow and you'll have more and more messages as we go along and more responses saved. We can also choose to set what the context window length means. So this pretty much, as it describes here, is how many past interactions can the agent actually remember. So we can change this number to pretty much, 10, 20, 30, whatever. And that would mean that the agent can actually remember more of our conversation. And then lastly, let's have a look inside what's happening in the vector database. So here, you can see the query that was forwarded by the agent to the database was opening hours Saturday. So it doesn't actually put through the whole sentence or the whole question. It's only going to pick out the important parts of the question and then forward it to the vector database. And you can see that the response that we got was, it's this whole text that we got from the database itself. And if you recall, this was one of the chunks that was made as part of that initial data insertion exercise that we performed. So this is the big chunk that we got back. And what the agent has done is it's taken this information and then picked out the specific information in relation to Saturday and the times, and then provided that back to us, the final answer. And one thing that I want to focus on is just this last node here to show you what exactly an embedding looks like. So if we double click on this, the query of opening hours Saturday, that gets forwarded onto this little node, and it's converted these words into a vector. So now you can see a vector is pretty much just a whole bunch of numbers. So these numbers then get fed into the vector database, and then whatever is closest representation to these numbers, that is how we get that output of text. And then, as I mentioned before, that text is forwarded back to the agent. So that is an end-to-end workflow of how a RAG AI agent works. And you can expand this functionality in much greater detail. So instead of just having a code block here, you can replace this with your Google Drive or your OneDrive, or pretty much any sort of mechanism which allows you to attach a file or retrieve a file. This agent itself, we can replace the in-memory database with PostgreSQL, or there's a whole different types of providers that we have. So if you have a look here, n8n allows you to put in different vector store providers, and also in terms of the embedding models, and you can also choose different types of embedding models or by different providers, by Anthropic, I think, and Mistral, and there's a whole heap of different ones that you can put here. If you enjoyed this video, feel free to leave me a thumbs up and subscribe for more videos like this. If you have an idea of what you'd like to see next on this channel, feel free to drop me a comment below. If you want to check out a video on how to build AI agents in Relevance AI, feel free to check out this video here where I've done the complete breakdown of how you can build an AI agent step by step. Or if you're interested more in how to build a WhatsApp AI agent, feel free to check out this video up here where I've broken down how to build a WhatsApp agent step by step. Thank you very much, and I'll see you in the next one.